Let A, B, C, D, E, F, G, H, I be distinct integers from 1 to 9. The minimum possible positive value of A, B, C minus D, E, F divided by G, H, I can be written as M over N. So we need to find the minimum possible value, positive value of this thing. Okay, now the common sense thing to do will be to put the biggest numbers on the denominator here, right? So the 7, 8, 9 on the bottom, because that will result in the biggest denominator possible. Oh, the bigger denominators means small all our fractions. Okay, so we're literally left with 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, but we already used 7, 8, 9 here, so yeah. Then we try and make the numerator as small as possible. So 1, 2, 3, 4, 5, 6. Let's see, 1, 2, 3, 4, 5, 6. How about the 2, 3, 36, and 1, 4, 5. That's, or maybe 2, 3, 5, and 1, 4, 6. That'll give us 30 and 24. 30 minus 24, that's 6. Of course, we can't get it smaller because we can't get anything between 24 and 30. Can we get 25? Nope, because 25 needs 2 5s. We only have 1 5. 26 is 2 times 13. We don't have a 13. 26, 7. It needs 3 3s. We only have 1 3 here and another 3 in this thing. So now 28 is 4 times that. Then we don't have 7. 28 needs a 7. 29 is prime. 29 is prime, so we can't get 29. So we can only get 24 and 30. So the numerator's minimum value has to be 6, right? Let's see. If it's 6, I guess this action may actually be counterintuitive. What if we make the numerator 1, then we get a fraction that's smaller than this? Huh? Okay. Let's see here. Let's say we want the numerator to be 1. So we want A, B, C minus D, E, F to be 1. Okay then, well, let's go through all the possible values of A, B, C or D, F, okay? Okay, we can... ABC cannot equal 1, or 2, or 3, or 4, or 5. But ABC can equal 6. 1 times 2 times 3. That's the minimum value of ABC, right? It can equal 6, and it can equal 8. That's 1 times 2 times 4. It can be equal to 10. It can be 12. It can be 14, and it can be 15. That's 1 times 3 times 5. It can be 16, which is 1 times 2 times 8. It can be 17. 17 is prime. We can form 17 by multiplying 3 of these numbers. We can get 18, which is both 1 times 2 times 9 and 1 times 3 times 6. We can't get 20 because, wait a second, we can get 20. We can get 20 by 1 times 4 times 5, but you can't get it by 1 times 2 times 10 because there's no 10. 20, okay, what else? We can get 21. Okay, that's 1 times 3 times 7. We can get 20. We can get 24. We can't get 22 because we need an 11. It's 2 times 22 is 2 times 11, and we don't have an 11 here. I actually memorized all the factorizations of all the numbers below 100, so it's gonna be pretty easy. 24. Okay, we can't get 25 because only one 5. Yeah, as we discussed, we can't get any of these. We can't get 30. Actually, we can't get 27. That is because 9 is allowed now. So 1 times 3 times 9. We can also get 28 because 7 is open. We can't get 29. We can't get 30. 1 times 5 times 6. We can get 32. 35. 36. 40. Okay, let's just speed through this, okay? 45. 45. Basically including everything that's in the times table. Okay, 49. Can I get 49? No, we can't get 49 because we only have one 7. 49 has 2 7s, so no 49. We can't get 50 either because that would require 2 5s, like 25. We can't get 25, we can't get 50. Okay, we can get 54, 56, 60, 63, 64. How do we get 64? Well, 2 times 4 times 8. 2 times 4 times 8, that's 8 times 8, which is 64. Okay, 60, we can't get 69, low 69, we can't get 70, 72, okay, 73, 74, 75. Okay, from this point on, we need to pay attention to the highly composite numbers, okay, and the 3 string ones as well. Okay, we can't get anything else in the 70s, I think. So 80. Can we get A1? No, because we only have a total of 3. Because, well, we do have 4 3s, but one of them is linked to a 2, so we can't get A1. Nope, no A1. We can't get A4 because that's 12 times 7. And which is 3 times 4 times 7, or 2 times 6 times 7, whichever you like. 90, 2 times 5 times 9, and 96, I guess. Yeah, 96. 12 times 8 is 96. Can we get 100? No. By the same logic that we can get 25, 50, and 75. Okay. I think there's no point going above 100. Why is that? Because if we go above 100, we're going to use some of these, we're going to use a lot of these big numbers, right? which would leave small numbers on the denominator. If we leave small numbers on the denominator, then, well, the fraction gets bigger, and we don't want that. We want a fraction to be as small as possible. So there's no point trying anything beyond 100, okay? Anyways, let's see. Now, we'll fit this. Maybe ABC is 15 and DF is 14. Yeah, not possible, because 15 is 1 times 3 times 5, and 14 is 1 times 2 times 7. We can't use the 1 twice. It's the same logic with the 16. 16 would be expressed as 1 times 2 times 8 in here. So yeah, we can't do 14, 15, or 15 and 16. Can we do 20, 21? Okay, let's see. This is 1 times 4 times 5. And this is 1 times 3 times 7. Nope, we cannot use 1 twice. We definitely cannot use the 1 twice. Okay, this is 1 times 3 times 9, and this is 1 times 4 times 7. We cannot use the 1 twice, ma'am. Okay, let's see. This is 1 times 3 times 5. I mean, wait a second. 1 times 5 times 7. And this can be expressed as 1 times 4 times 9. But there's also another option. You can write it as 2 times 3 times 6. Okay, so 35, 36 is possible, okay? Let's try it out. 35 and 36, this is 2 times 3 times 6 minus 1 times 5 times 7. Okay, that leaves us a 4 and 8 and a 9 for the denominator, with 4 times 8 times 9, 1 over this. 72 times 4, 428. 288. 1 over 288. Okay. Okay. So yeah, that's pretty small. Okay. Can we get smaller? Like, can we get smaller with the 63 and 64? 64 is 1 times. 64 is 2 times 4 times 8. This is 1 times 7 times 9. Okay, what do we get here? 2 times 4 times 8 minus 1 times 7 times 9 divided by 3 times 5 times 6. 3 times 5 times 6 is obviously smaller than 4 times 8 times 9. Okay, this is obviously smaller than this. In fact, this is actually 1 over 90, way smaller. We do not need this, okay? So, our current candidate is 1 over 288, which is definitely bigger than this. It's definitely bigger than this, okay? But how do we prove that it's the actual minimum possible value? How do we prove that we can't get smaller than this? Okay, let's see. We now made we just got this by making the numerator 1. Now, how about we set the numerator to 2 and see what happens? Let's say we set this ABC minus DF is equal to 2, then this would be greater than 7 times 8 times 9, then greater than 2 over 7 times 8 times 9, right? Since you know the denominator is smaller than 7 times 8 times 9. Which is, this thing is actually greater than, it's actually equal to, look, divide these two by 2, we get 4 times 7 times 9, so 1. Definitely greater than 4 times 8 times 9. 1 over 4 times 8 times 9. And look, if this thing is equal to 3, we will get even greater than that. So yeah, the minimum possible positive value is definitely 1 over 288. So find m plus n. So we add 1 plus 288 together, that's 289. So the answer, we already have it, it's 289. Okay.